Advanced subsea technologies offer new prospects for development of oil, gas, and condensate fields on the offshore shelf of Russia. Межрегион Трубопровод Stroy Company started offshore construction in 2005. And in 2013, acting as an EPC contractor for GSC Gazprom, it implemented the project of Kirinskaya gas condensate field development in the Sea of Okhotsk as part of the Sakhalin 3 project. Design engineers faced a complicated challenge: to collect the product at deep sea level and to transport it to shore. The concept of field development covered several options of hydrocarbon production. As a result, it was decided to construct the subsea production system of Kirinskaya GCF at 100-meter sea depth. According to the design, the system includes 6 production wells, a manifold, a 20-inch gas-gathering header, and a 4.5-inch monoethylene glycol pipeline, in-field flow lines, systems of umbilicals for onshore remote control of the subsea production system. The project is unique in that it is the first time in Russia when hydrocarbons are produced in the offshore field without topside platforms. So far, no Russian companies have ever participated in such products either in our country or abroad. At the project, the main scope of pipelay work has been accomplished with the use of the Fortuna barge. The first step is to supply a pipe to the firing line, removed from the pipe ends, and the pipe is inspected. Then the pipe moves to the welding workshop to the longitudinal conveyor, where the pipe edges are beveled and processed with the help of a portable defrazing tool. And then the pipes are heated by induction up to 120-150 degrees. The pipe prepared for welding is forwarded to the welding conveyor. The field joint takes several steps. At the first welding station, the pipe joint is assembled and aligned with the use of an internal pneumatic clamp. This is followed by welding of root weld. The filling and final facing runs of the weld joint are completed as the joint moves along the welding conveyor. Once the welding is completed, the field joint is non-destructively tested with the use of automatic ultrasonic test equipment. After a successful ultrasonic test, the field joint moves to the blasting station where the pipe metal is cleaned from all possible contaminants and prepared for application of thermal insulation. Then the joint reaches the station where it is covered with insulation coating to protect it against corrosion. For this purpose, the metal is preheated to improve adhesion with the insulation material. The final step before the field joint goes underwater is filling of interjoint space with polyurethane foam to ensure mechanical protection of the insulation against any damage. At all stations, the operations are carried out simultaneously. Every station of the welding line is equipped with a signal system connected to the central control panel, which the operator uses to announce that the operation is complete at the respective station. Once the operations are completed at all stations, the shift supervisor gives a command to the central control bridge that the vessel can move further, pulling the pipe joint for its lay to the seabed. The PLB Nebula is a vessel laying the pipes at the project. The undeniable advantage of this vessel is a shallow draft which enables installation and lay of pipelines in shallow waters. The operation of a particular complexity is a pipe lay at landfall. The best possible method for this operation is a shore pull-in. The pulling force is the crucial factor for such an operation. In order to improve the pull-in process, it's required to ensure the closest possible approach of the pipe-lay barge to the shore. In such cases, the shallow draft nebula is irreplaceable. The main point of shore pull-in operation is the buildup of pipeline strings is similar to the ordinary pipe-lay operation on board the PLB. When the string is built up successfully, section by section, and the complete pipeline is pulled to shore by hydraulic winch. As there is a high probability that the trench might be washed off, the design provides for construction of a protection cofferdam which maintains integrity of the trench and protects the pipeline against wave battering during storms. Once the pipeline reaches the design position on shore, the barge is instructed to start a normal pipe lay process. Ten and 8-inch inline tees are installed in the process of welding and lay of infield flow lines of 273 millimeter diameter to the seabed. The inline tees are installed to the pipeline on the longitudinal welding conveyor. Inline tees are fed to the welding conveyor through the hatch of the fireline roof located above the 7th welding station. Further, with the help of telfers, the inline tee is transferred to the 4th welding station, where the inline tee is then welded to the pipeline sections. Once welding of the inline tee to the pipeline string is completed, as the inline tee moves along the welding conveyor, its vertical position is controlled with the help of the telfer line. When the inline tee is moving through the tensioners, the pipeline tension is maintained with the help of the hoisting winch. After the inline tee has come off the stinger and has been submerged into the water, the vertical position of the inline tee is maintained with the help of a pre-installed buoyancy module. In the process of installation, the vertical position of the inline tee on the seabed is kept stable with the use of 2 horizontal supports. To reduce dimensions of inline tee, these supports have been folded and secured with holding slings. The holding slings shall be removed and the support shall be opened underwater with the help of a remotely operated vehicle 0.5 meters before the inline tee reaches the seabed. After installation to the seabed, the remotely operated vehicle surveys the installed inline tee and removes the buoyancy module. The installation of pipeline end terminations, plets, starts once the pipeline is laid to the seabed. The installation involves recovery of the laid pipeline string alongside the barge and further welding of plets at the tie-in station. As in the case of pipeline lay from the stinger, the main challenge of pipeline recovery alongside the barge is to keep the right S-shaped curve of pipeline. The pipeline is recovered with the use of special lifting equipment fitted along the port side of the barge. For the purpose of pipeline recovery, 5 clamps have been pre-installed in the pipe string during the lay operations. When the pipeline is recovered to the level of the tie-in station and the temporary head is removed, a pipeline and termination is supplied to the free end of the pipeline by crawler crane. Plet is then aligned relatively to the pipeline, welded, and insulated in the joint. In total, 6 plets have been installed. The main task was to load 350-ton reels on board. The umbilical reels were transshipped from transportation barge to PLB Fortuna in the Sea of Okhotsk. The weight of each reel is 350 tons. The loading was performed by a 1,600-ton crane installed aboard PLB Fortuna. This type of operation was classified as an extra heavy cargo lifting operation. The operation was held in the open sea outside the field. Once the reels had been loaded, they were placed to the stationary positions in the cable lay system, which had been pre-installed to the PLB Fortuna at the preparatory stage of works. For the purpose of umbilical lay work, the PLB Fortuna was fitted out with special equipment within the shortest possible time. A reel drive system, an internal chute, a tensioner, an overboard chute. Mrts has many years' experience in construction of subsea pipelines for the oil and gas industry. The company is particularly proud of its own marine spread, which is unique and knows no equals in Russia. The Mrts squadron includes primarily 3 pipe-lay barges: Fortuna, Mrts Defender, and Nebula, special purpose vessel Kendrick, as well as a score of vessels and watercraft enabling to perform a wide range of work in both offshore and nearshore areas. MRT has diving specialists with a permit to work at depths reaching 300 meters. Mrts Engineering Company has been created for the purpose of work under the EPC contract pattern. The example of efficient work under the EPC model is the development of Kirinskaya gas condensate field. In this case, the contractor can manage the full cycle of the project, including control of cost and expenses. The EPC contractor fully accomplishes the investment project from the design stage to handover of the complete site to the client, including warranty obligations. This enables maximum effective management of financial costs and maximum profit without quality loss or construction schedule delay. The project of the Kirinskaya GCF development demonstrates how the Russian company working in oil and gas construction industry functions as the EPC contractor under turnkey projects. Today, Mrts, having its own marine spread, separate engineering center, its own developed logistic base, the most advanced equipment, and highly qualified personnel, is able to accomplish almost any scope of work. Surveys, design and expertise, order and supply of equipment, lay of pipelines and umbilicals, subsea engineering works associated with site preparation for development, dredging, installation of subsea equipment, installation of onshore control system, commissioning and testing, well hookup, drilling. Involvement of Mrts in EPC project as the sole EPC contractor has fundamentally increased competitiveness of Mrts both in Russian and international markets of construction and installation services in the fuel and energy industry.